Okay, so the first thing to look at this function, so f of x is equal to x cubed minus 3x squared minus 9x plus 1. So we know it's a cubic function because there's an x cubed in it. With cubic functions, when they're graph, we know there's a maximum and a minimum point. So we know when we find the turning points in this graph, there'll actually be two. So first things that they asked us to do is find f dash of x, meaning that we differentiate. So differentiate x cubed, bring down your 3, multiply by what's there, and reduce your power by 1, so that becomes 3x squared. Next one, bring down your power, multiply by what's there, so minus 3x squared becomes minus 6x. Minus 9x becomes minus 9, and then plus 1 when you differentiate, it doesn't become anything. So that's it, simple. So the next thing, part 2, it asks us to find the local maximum and local minimum point. This is also called the turning points. We know the steps that we have to use to find this. So we know we have to find f dash of x first. We have to let it equal 0. We find our x values. And then we must go and find our y values. And that's our 4 steps for finding the maximum and the minimum, or else finding the turning points, whichever you want to call it, or whichever they call it on the day. So the first part, f dash of x, right? So we've already found that. So we know that f dash of x is equal to 3x squared minus 6x minus 9. Step 2 is let it equal 0. So we let it equal 0 here now. Right, so we have an x squared here, an x and a number. So in our head straight away we're thinking minus b formula or open up our brackets. So see, can we simplify it anyway for opening our brackets? So we know that that'll divide across by 3. So it becomes x squared minus 2x minus 9, or minus 3, now, equals 0. Because we've divided each element by 3. Therefore, it makes it really easy for us to open up brackets. And moving on to our third point of finding the x values. So x squared gives us 2x values. Factors of 3, that'll give us minus 2, so 3 and 1. Inside by inside will give us 3x. Outside by outside, 1x. We need a minus 2x. How do we get that? Well, minus 3 plus 1 will give us minus 2. So minus 3 plus 1, so x minus 3 equals 0. X equals 0 plus 3, so x is 3. X plus 1 is equal to 0. X equals minus 1. So we're after finding our two x values, and as we said at the beginning, it's a cubic graph, so we know we're going to have a maximum and a minimum. So one of our points, the x value is a 3, and one of their points, so maximum or minimum, the x value is going to be minus 1. Now we have to go back to step 4 of it, so find the y values. So in order to find the y values, we have to sub it back into the initial equation, because if we were to sub it back into this equation here, the f dash of x at the very beginning, that doesn't mean y. That's the differential of y. So we have to sub it back into y, which is what they gave us in the question, f of x, right? So we just write out the sum. So f of x is equal to x cubed minus 3x squared minus 9x minus 1. And we know that f of x actually means y. So what we're going to do is sub back in the x values. So we'll let x equal 3 first to find the first point. So we'll have 3 cubed minus 3 times 3 squared minus 9 times 3 minus 1. So 3 cubed will give us 27 minus 3 times 9 squared, or 3 squared gives 9 minus 27 minus 1. And that will give us 27 minus 27 minus 27 minus 1. Sorry, it's plus 1 all that time there. So that will give us minus 26. Our point therefore is 3 is our x value, and minus 26 is our y value. Now we have to do the exact same thing, except we have to let x equal to minus 1. So when x equals minus 1, we'll have sub it back into our f of x equation. So minus 1 cubed minus 3 minus 1 squared minus 9 times minus 1 plus 1. So minus 1 cubed gives minus 1, minus 3 and minus 1 squared will be plus 1 plus 9 plus 1. So that will be minus 1 minus 3 plus 10. And that will give us 6. Minus 4 plus 10, yes, 6. So our point there will be minus 1 and 6. So now we have both our turning points. So we have our maximum and our minimum. What if they asked us to identify which one is the maximum, which one is the minimum? So over here, I'm just going to draw a really rough graph, okay? So we always look at the y values, okay? So 3 and minus 26. So roughly if I was to draw that, it'd be somewhere like that. 3 on x minus 26 on y. If I was to draw the minus 1, 6, it'd be somewhere over here, minus 1, 6. Something like that if I was drawing my graph. By looking at that graph, I know that minus 1, 6 is there going to be for a maximum point, because if we imagine our cubic graph going something like this, the lower the y value, the lower y value will always be our minimum point, because that'll be lower on the graph. So what was that one? 3 minus 26. So therefore we could say that minus 1, 6 is our max value, and minus 26, 3 minus 26 is our minimum value. So just to recap on that, the lower y value, so like always, like roughly plot your points and it makes sense. So the y value here is 6, so 6 is around there. The y value of the other point, minus 26,